Hi, I'm Michael Bernstein, the development lead for accessibility on Windows 7, and I'm here to give you an exclusive web look at the new automation and accessibility APIs for Windows 7. We're really excited about these new COM APIs. They make possible an interaction and a depth of data with accessibility that haven't been possible before, and so I'm thrilled to be here to give you a quick run through them. My background, I've been at Microsoft for about 8 years, and I'm a development lead on the team that builds the accessibility features for Windows 7, and it's great to be here with you. So I want to jump right in and talk about the name of the game, which is programmatic UI access. It's not the whole of accessibility, but it's an important part, and that's what the core of this talk is about. Programmatic UI access is all about finding UI on the screen, querying it, manipulating it, and getting events on it when it changes. So this is crucial for two different audiences. Accessibility tools like screen readers and magnifiers and on-screen keyboards, this is bread and butter for them because this is how they interact with applications. It's also crucial for an entirely different audience, test automation. Test automators want to do very much the same thing. They need to find UI and interact with it to validate that applications are working properly. So for either audience, this is crucial technology. In Windows, our best vehicle for programmatic access is called UI automation. UI automation is a successor to Microsoft Active Accessibility. MSAA was a technology we introduced in 1995. It did very well for about 10 years, but we came to know that it had some limitations and wanted to build something better. And so in Vista, we introduced the UI automation system. UIA creates a universal object model for UI. So no matter where the UI is coming from, whether it's a WPF application or a Win32 app, even a web app running in a browser, it always appears the same. You can use the same object model and interact with that UI in precisely the same way. We built it based on our experience with MSAA, so many of the limitations in MSAA, if you've run up against them, have been solved in UIA. It's a much nicer experience. Now I mentioned that it was introduced in Vista, and it was. It came out for the first time with Vista, and it also shipped with the .NET framework to make it available on XP and Server 03. What's new in Windows 7 is that we've added a COM client API. So if you look closely at the diagram, there's a provider piece of the UI automation core, and there's a managed client in Vista, but there was never a way to get to accessibility data from native code in UIA. So in Windows 7, we introduced the new UIA COM client API, making it possible for native applications to interact with UI on screen for the first time in a smooth way. And we're really excited about this. So when I talk about what's new in Windows 7, I wanted to take a minute and just summarize it top to bottom as kind of a sketch for the talk. The COM API is huge, and that's the biggest new thing, and that's where I'll spend most of my time on this talk. But there are a few other things that are new. We added some new accessibility properties to the system so that you can ask new kinds of questions about target applications. We also made it possible for native client applications to register custom proxies so that existing applications can be made more accessible or flaws in those applications can be worked around. And I'll talk more in depth about that later in the talk. And we also added a custom extensibility mechanism so that properties and patterns that we never thought of, that aren't on the official list, can also be queried and interacted with through UIA. The custom extensibility mechanism is very powerful and provides a way to solve problems that we didn't think of and may not get to until a later release. So we're really excited about that as well, and I'll also touch on that somewhat later. But before I can really get to those, I need to lay a little groundwork, and I really want to talk about the COM client API. So let's start with a demo. If you haven't worked with accessibility, you may be wondering exactly what this is about, and I think the demo will help clarify. So what I'm going to do here is I'm going to start a tool called Inspect. Inspect is an existing tool, and you may have used it already. This is Inspect 2, which is a prototype my team put together that extends Inspect to work on UI automation. So Inspect is running over here, and let me get something to look at. It just so happens that the mouse control panel turns out to have a lot of good controls, so we'll just use that. So here in the mouse control panel, here's inspect running, and each time I hover over something new, it goes and queries the accessibility properties. So for instance, let me pick a button. Let's start with the OK button. So as I hover over the OK button, the inspect window fills in with a list of properties. Now, it's a little hard to read, so let me use the new Win 7 magnifier to zoom in on what I'm doing here. I'll hover over that again and come over here and take a look. So some important stuff to see here. There's for each item. Oh, I'm sorry. I'm still in MSAA mode, which is the old style one. So let me switch this over to the new UI automation mode. Do that again. There we go. Okay. So in UI automation, I get a list of the most important properties about this object top to bottom. So you can see things like its screen location, the control type, which is an enumeration, 50,000 means button, its localized control type, which is the same thing but in the user's local language, the name, things like whether it has keyboard focus or can have focus, its automation ID, which is an important piece I'll come back to in a few minutes, and many other features, many other interesting bits of data about this control. If I switch to a different control, so let's hover over a combo box, for example. So looking at this combo box, you can see what's changed. The control type is different. 50,003 is the combo box control type, and the localized control type reflects that. The name is different. It's called scheme, and it's got an access key, and it's a combo box, so its properties are different. So far, all I've done is query properties about the object, but I can also manipulate it, and this is really cool. So I'm going to hop out for a minute here. And since it's a combo box, under the action menu, I get specific actions that make sense for combo boxes. This is really different from MSAA, by the way, if you've used that. MSAA just allowed you to do one action on each item, but in UIA, any actions the item chooses to expose can be done. So in this case, since it's a combo box, I can expand or collapse it. So I might expand it. Now if I switch over to a button, if I switch to the OK button, I don't have expand collapse anymore because those don't make sense for a combo box, but they do make sense for a button. So but invoke does make sense for a button. So if I hit invoke, I will invoke the OK button, which will dismiss the dialog. So there's a quick run through inspect. Now, you got a chance to get rid of the magnifier. When you're looking at inspect, you're seeing these properties come through, and it's always a kind of partnership. So there's a client, in our case inspect, which is querying those properties. And then there's a provider, which is providing the accessibility data about them. And so in any case like this, there's two players, in fact 3 players, a client, a provider, and then the UI infrastructure that is providing the glue and routing the data back and forth. In Vista, in our original release of UIA, providers could be written in either native or managed code, but clients had to be managed code. But now, with the new COM API, clients can also be written in native code. You'll see this diagram a whole bunch of times. I'm going to use this to structure our talk. And the first place I want to go is the client. I want to talk about the COM client and how it makes it possible to ask questions and manipulate UI from native code. Let's start with a code sample. I love code samples. I'm sure you do too. And I really like this one because I'm doing something that really you couldn't do any other way besides UI automation. I'm asking a specific question, which is the current focused control one that is a password field? Is this a field where you shouldn't echo keystrokes? And this code is actually taken almost verbatim, very similar code, runs in Windows itself in the on-screen keyboard. When the on-screen keyboard is typing into a password field, you don't want to echo the keystrokes in the same way that you usually do. So it's imperative that the on-screen keyboard be able to find out if something is a secure field. But how do you do that? The secure field setting is different between Win32 and between like an edit control and a secure field that's in a web page and a secure field in a WPF app. There's no general way to do it. So in UIA, you can do this in just 3 lines of code. So first, we're going to co-create an instance of the CUI automation object, which is our class factory. It's kind of the gateway to everything else that you do in UI automation. From there, we're going to call getFocusedElement, which goes and gets the current element with keyboard focus and hands it back to you as an IUI automation element. IUI automation is the gateway to a whole bunch of useful properties that make sense across almost all UI. And one of the fields on it is whether something is a password-protected object or not. I'm sorry, is a secured object, an object where you might enter a password. So once we've got the element, you can just ask for that property. We call getCurrentIsPassword, which means get me the isPassword property, and I want the current version. I want to know right now, is it a password field or not? And it's going to hand me back a Boolean, and I'm done. In 3 lines of code, I've managed to find out whether something is a password field, regardless of its underlying UI framework. That's the power of UIA. So let's walk through that in a little more depth. The place where we started was an automation element. Now, if you happen to be familiar with the managed UIA client, if you've worked with UI automation before, automation elements will sound very familiar. This is deliberate. We designed the COM client API to look very similar to the managed API so that if you've used one, you can move over to the other fairly smoothly. The concepts are very much the same, although there are a few differences in how they're realized. So automation element is a common concept, and it always represents a single piece of UI regardless of the underlying implementation. To get one, first you're going to co-create the CUI automation object. It's pretty much the factory for the object model, if you're familiar with the factory design pattern. Next, you're going to get an element, and CUI automation can help you get an element in a variety of different ways. You can, if you have an hwind, you can call element from handle and get an element that way. If you know the location, you can call element from point, which will hit test and get you the element. And I showed you getFocusedElement, and there are a few other ways as well. Each of these returns the same kind of object, an IUI automation element interface. Once you've got one of the first things you probably want to do with it is access its properties. It supports a wide variety of properties that, at least as far as we can tell, apply to almost all UI. The properties are exposed in a COM way, so they're pretty much all get underscore something, like get underscore current name or get underscore current is password. And they're consistent across all underlying UI. So just to make this crystal clear, if you look at the table on the slide, I gave 3 examples. If you had a button that you declared in a WPF application, you would set the content field on that button to set the name that's displayed on the screen. If you had a Win32 button, you would construct it and then call setWindowText to set its text. Or maybe you would do that in a dialog template. And if you were a web page and you had an image, you might put an alt tag on that image to give a text-readable name for that image. 3 very different kinds of content, but in all 3 cases, that text is exposed as the name property in UIA. So this is how we provide consistency. We encapsulate the different UI frameworks to give you a consistent UI automation experience. There are a long list of properties, and if you go to the MSDN Accessibility Developer Center, you can find good references on UI automation. Another good place to get a full list of the properties is in the Community Promise spec, which you can also find in the Developer Center. But I wanted to touch on 3 particular properties. If you don't remember any others, I hope you'll remember these 3. The first is the name property. And the name of a control really should correspond to what the name is on the screen, or what the user would say if he or she was trying to refer to that control. A control without a name, an accessible name, would be kind of like a button without a label, and just as useful to the user. Just like your user isn't going to click a button that has no label on it because they have no idea what it's going to do. a control without an accessible name is totally useless to someone who's trying to use it via a screen reader. So the name property is key, and very much like the label on a button, you would expect name to be localized. Also, very much like controls on a dialog, you could conceivably have two controls on the same window, the same dialog, that have the same name. So for instance, in the mouse control panel, there was a group box that said scheme, and within it, there was a combo box whose name was scheme. So they both have the name scheme. So that's the name property. The second property I want to emphasize is the control type property. Control type, you might say, is like the shape of a control in accessibility. Control types are things like button, combo box, split button, table, text. They describe what the control is, and control type is a numeric enumeration. So it's not localized, and it works across all languages. And so control type could help you distinguish between scheme, the group box, and scheme, the combo box within it, because they would have different control types. The third property I wanted to mention is called automation ID. Now, name and control type are required properties. They have to be there. Automation ID is not required, but it's strongly recommended because it solves a very particular problem. If you're trying to write test automation that invokes a particular control, or if you're trying to do an accessibility script that pushes a particular button, you've got to be able to find that button. But if you try to find it using its English name, then when your script runs on a French version of your program, it won't work, it won't find it. And so you have this problem. How do you find a control if you can't rely on its name being constant across languages? And that's where automation ID comes in. Automation ID uniquely identifies an element among its siblings, and it can be made unique even between controls with the same name, even controls with the same name and same control type. It's just a string, and so it's up to the developer to assign unique automation IDs, but it's well worth the effort because it makes automating that application and testing it later much easier. So 3 key properties: name, control type, automation ID. And for the full list, go check out the Community Promise spec. So far, all we've talked about are properties of UI, just read-only. What if you wanted to manipulate UI? You know, like I showed you, you can invoke and expand. How does that work? Control patterns are the key to how you manipulate UI. And this is one of my favorite pieces of UI automation. I think control patterns are awesome because they bring object orientation to accessibility. A control pattern is very much like an interface. You only expose the ones you need to. So they provide access to a control's unique abilities, the abilities that make it different from other controls. So for instance, there's no control pattern for button. Instead, you have an ability, invoke. Buttons can be invoked, so buttons expose the invoke pattern. The invoke pattern says, I can be pushed. The transform pattern says, I can be moved. A scroll pattern says, I can be scrolled. And a selection item pattern says, I can be selected. So you choose the control patterns that make sense for your particular control and expose those. So for a combo box, for instance, a combo box has the simple pattern. That's the one that they all have that exposes the basic elements. And then it has the expand collapse pattern, because that makes sense for a combo box. And it has the value pattern, which exposes the ability to set and get a control's content, its value, what's selected in the combo box. But there's no invoke pattern because it doesn't make sense to push a combo box. You don't invoke it. You might open it, but you don't invoke it. And so you can see, if you imagined if there were a custom control that could be both expanded and invoked, then it would just expose both of those patterns. So there's a ton of flexibility here that makes it possible to create great automation experiences for each control. I've really emphasized controls. I've really emphasized the methods on a pattern, like what can you do with it. But patterns can also have special properties and events. So for instance, the value pattern has a method, set value, and a property, get value. The invoke pattern has a method, invoke, and an event, invoked, indicating that the thing was invoked. So control patterns do provide kind of packaging for properties and events as well as methods. So that's how you manipulate UI. Now, how do you find it? I gave you a few examples earlier. You could get focused element, or you could drill element from point. But if you needed to find a specific piece of UI that you didn't know the location already, then you would want to use a find request. Find requests allow you to locate elements anywhere in the automation tree, the accessibility tree for an application, based on conditions. The most basic condition is to look by property. So I want the control with name equals scheme, or I want the control with control type equals combo box. And then you can yoke these things together with Booleans. So I want name equals scheme and type equals combo box, or, and so forth. They're and or not, the basic Boolean elements. Requests can be restricted by scope. So you could say, I want to look through the entire subtree of my application, or you could say, I only want to look through the direct children of a particular node. You can also look through ancestors. So you can set the scope. You can also decide if you want the find request to return just the first match, or all matches, which would come back in an array. The best thing about find requests is that they're really fast. One thing to emphasize about UI automation is that it's almost always cross-process. The inspect process was talking to the mouse control panel, for example. So if you were to search manually, walking from node to node, every node-to-node transition would be a cross-process call, and every query would be cross-process. But with a find request, I can send a single cross-process request from the client to the provider that says, I want to do a find and here are the criteria. It can do the search, marshal everything up, and then pass the results back to the client in one call. So it's a great chunky interface, and it's highly performant for that reason. It is possible that you would have to do a search that would exceed the abilities of find requests if we didn't think exactly what you wanted to be doing, or if you wanted to enumerate a tree. And so to do that, we do give you that ability, and you use a tree walker object. Tree walkers are simple objects that help you to move through the tree. I've mentioned earlier, everything's organized into a tree. I just wanted to give you an example. If you had a list view control, that list view control has a node that represents the whole control, and then it has child elements. So each item in the list view would be a child. I showed list item 1 and list item 2. There's probably a bunch more. And then if it's a scrolling list view, it would also have a scroll bar child. And that scroll bar child would have its own children, the up button and the down button, and the other parts of that control. So everything's organized into this great big tree. And tree walkers let you navigate around the tree. It has methods like getParentElement, where you would pass in an element and it returns the parent. GetFirstChild, getNextSibling, all the things that you would expect trying to navigate around a tree. But tree walkers are cooler than that. You actually can filter by condition. So if you wanted to look at only a subset of the tree, suppose you only wanted to look at tree elements that are visible on screen, you'd set up a filter with off-screen equals false, and filter on that, and you would get a filtered tree that you could then walk around as though it were the only tree in existence. You could also filter on whether something is a control or whether something is content. So there are a lot of powerful abilities here, and that's why tree walker is a separate object. You create a tree walker object, you set the filtering conditions you want on it, and then you use it to move around the tree. I do want to reiterate that there are performance costs to using a tree walker. Every call on a tree walker is probably a cross-process call. So use them if you need to, but not if you don't have to. Our quick spin through the client API wouldn't be complete if we didn't touch on events. Events give you the ability to be notified whenever changes happen in your UI. The listening mechanism is very COM. You're going to implement a COM object that implements a particular listener interface, and then you register that listener with the CUI automation object. And from then on, whenever events are fired, you get a callback on your listener interface. Usually in COM, you just subscribe to elements on a particular object, in our case, a particular element. But we didn't do it that way because we wanted to make it possible for you to listen to an entire subtree. So you can put a listener on, say, the root of a list view, saying anytime anything changes within that whole list view, I want to be notified at the root. And so you can listen to an entire subtree without putting listeners on every little child of that subtree. It's very powerful. And for that reason, the registration for listeners happens on the CUI automation object and not on the element itself. When an event is fired, though, it always comes with a reference to the particular element that fired it so that you will know which one fired it, and you can ask questions about that element, check its properties, manipulate it, etc. I only have time for this quick spin through events, but there's a reference to the event API on MSDN on this slide so that you can look for more information. All right, that's enough talking. Now it's time for a demo. The dump UIA tree is a little prototype I wrote to just run through a tree. It's not posted, but it's not particularly good either, so you're not missing much, and we'll get better samples up on MSDN for you to look at. But I did want to show you this one. You know, I wrote it. I'm proud of it. So what dump UIA tree does is, let's get a command prompt here. So what dump UIA tree is going to do is iterate through an entire tree and just dump it out on the console for me with a few properties I was interested in. It can dump any tree. I think I'll dump Excel. It's a good target, it's pretty big, and also it implements custom accessibility. So it's a good example of how the fact that this is particular Office accessibility doesn't bother UIA. It still comes through in the same way as anything else would. So I'll ask for a list of properties here, and Excel is 704, so we'll do, you don't need to remember any of this. This is just my, my tool anyway. So what it did is it used a tree walker to run through all of the UI in Excel. And for each one, I'm dumping name and control type and a few other things. So you can kind of see some familiar stuff here. You can see the ribbon, and you can see some of the stuff that's on the ribbon. There's some split buttons. There's a title bar. There's some tabs. So so you can see the basic accessibility data here. This is a pretty easy program to write. It's basically just 4 functions. The first thing we want to do is initialize. As I said, this is prototype code. You'd usually just use co-create instance, but you co-create a UI automation object, and then I'm going to get a tree walker while I'm initializing and just store that. So I got a raw view walker, which means I want to look at everything. So then when I try to dump the hwind, I'm going to ask the factory for element from handle. I'm going to ask for a particular element based on the hwind, and I get the element back. And from there, I'm just going to call a recursive dump function. It's a tree, it's recursive, you knew it would be. So in that function, for each element, it calls print element. And print element is going to use those property accessors I talked about before. For each element, it's going to say, what's the current name? And it comes back as a beaster. What's the current localized control type? What's the current control type, which comes back as an integer? And I've got some printfs that format this into a string. I also ask for the off-screen property, which is a Boolean, just to see whether something is off-screen or not. And then I print that out. Nothing particularly complicated. The more interesting code is in the recursive call, which is dump element. What dump element is going to do, it's going to print the element, and then it's going to call on the tree walker get first child element. If this succeeds, then there's children. So we'll go ahead and print an open brace, and we'll go into a do while loop to dump each child element. And then once the dumping is done, we go back to the tree walker and call get next sibling, which will pass us the next sibling. And if there is a next sibling, then we'll recurse and dump that one. So we recurse through the tree with the tree walker, and then close out the braces, and we're done. So very straightforward to dump a whole UIA tree. Interestingly, I didn't have to know anything about Office accessibility. It would work equally well on a WPF app or on a Win32 app. No target knowledge necessary. It just dumps the whole tree. So that's dump UIA tree. And it gives you a sense of how easy it is to get access to the accessibility data. Now, I told you earlier that using a tree walker was cautioned against because of its performance characteristics. And that's quite true. And since dumping a tree or accessing all of the information in a tree is a pretty common task, it would be sad if you had to use a tree walker for it. But you don't. There's a great facility in UI automation called cache requests that is precisely built to solve this problem. A cache request is a way of ticking off multiple items on the menu, you might say. I want to know the name, the localized control type, and off-screen for all the children and all their children and the whole tree underneath. Go. So you build up a cache request, you add entries for all the things you're interested in, you define a scope, you can even add a filter, just like a find request. You can set property conditions for the stuff that you're interested in. And then you call build updated cache. On any element, you can call build updated cache, pass it a cache request. It'll hand you back a new element that corresponds to the same piece of UI, but now has a whole bunch of cache data attached to it. There's also a family of methods in UIA that have a build cache suffix that do the same thing. So if you call element from handle build cache, it will go to that H when you pass it, get you a reference to the element, but also cache everything that you asked for while it's over there, doing the whole thing in just one cross-process call. Once you've got that object back, you access the properties in almost the same way, but you use the cached flavor of accessors. So get cached name, get cached control type, and so forth, to make sure that you are looking at the cache data. Children can be cached as well. So let's go back to dump UIA tree and see what it would look like with the caching enabled. So if I come back here and I run my version that uses caching, the aptly named dump UIA tree fast, it's going to do that whole tree, and whereas the first time it took 1,400 milliseconds to dump the tree, this time it took 687 milliseconds, half the time. And if some of that runtime is spent dumping to the console, but I can go back and dump them to text files. So dumping to a text file with the tree walker took 421 milliseconds, and dumping with the cache request took 172. It's more than twice as fast. And the bigger your target app, the more data you want to bring back, the more advantageous it is to do it all in one chunk rather than in a bunch of chatty calls. So this is huge. The performance implications are very important, and it's a great way to speed up your accessibility or your automation access. Now let's run back to that source code and just see what changed. Scroll down to my fast version. So the initialization in the fast version got a little more complicated. Instead of, after we do the CUI automation, we don't make a tree walker. This time we're going to make a cache request. We call create cache request. We tell it we want the whole subtree. We want name, localized control type is off screen. We put in a raw view condition indicating we want to see everything regardless of property. And there's an optimization at the end here where I say, because I'm only going to consume the data, I'm never going to use the element after I dump it, I say, don't bother bringing me back live references to what is in the target app. If you were going to use the cache data and then ask for current data and see if it were different, you might want the live references, but I don't. So I set it to none, which makes it just a little bit faster. So now I've got the cache request set up. So dump window is almost the same as before, except instead of element from handle, I'm going to use element from handle build cache, which, as I said, does the whole process in one trip and brings me back all my cache data. Print element has hardly changed at all, except that I'm now using the cached accessors, get cache name, get cached control type. So hardly any changes there. The one function that did change substantially is dump element, because the recursion is different. Instead of using a tree walker to recurse through the tree, I have cached children. So I'm going to retrieve those children from the cache and process them as arrays. So for example, I'm going to, for each recursive call, I'm going to print the element, and then I'm going to ask for its cached children. And if it has any, I'll go ahead and get the length of that array, print the braces, and walk through the array, getting each element by index, and dumping it. That's it. That's the whole thing. So by just changing a few lines and by rewriting the recursion, I got it to be twice as fast. And this is a huge ability, and as I said, we're really excited about it. That ends my spin through the client. Now I want to take a moment to talk about what's new in the infrastructure. Most of the time the infrastructure is completely invisible to you, but we added some new properties and patterns that are good for you to be aware of because they allow you to ask questions about UI that you couldn't ask before. The most complicated and interesting patterns we have that are new are patterns for control virtualization. There are a set of controls that have, we might call them virtualized controls, that have more content than they show. So a classic example would be a file browser. You might be in a directory with 100,000 files, but you're only showing maybe 30 at a time, and it would be wasteful to go query the ones you're not showing. So you only have the data in memory for the 30 that you're showing. A user who's scrolling through it can see from the scroll bar that there's more data. But from an accessibility perspective, it's hard to see that there's more data. All you're going to see are the 30 elements. The virtualizing patterns allow a control to express, I have more data than I'm showing. And it really comes down to two patterns. The first is a pattern on the container that allows you to search for objects by property that aren't visible in the control yet. So you could go back to the file control and say, do you have, in the middle of your 100,000, is there an element by the name of foo.txt? And it would go do its own search and come back and say, yeah, there is. It just happens to be off screen. And would hand you back an element reference for the virtualized element. And then the other pattern is one that virtualized element would expose that would allow you to de-virtualize the element on request, which would tell the control that you want it to go ahead and page in the data for that because you're going to start asking questions. Oftentimes, like in our example, that might just scroll the whole file window to show the file that you just de-virtualized, but it doesn't have to. So this is very useful for containers with massive numbers of children, and it's good to know about on the client side because you may run across these controls that have more data than they're telling. Some of the other new properties and patterns that I'll touch on a little more briefly. We have a set of ARIA properties. If you are familiar with ARIA, if you're not familiar with it, it's a spec for accessibility in live web apps like AJAX applications. And so AJAX apps can annotate their markup with ARIA properties to say what their accessibility should be. Now UIA will go and look at the ARIA role for each item in that AJAX app and expose it properly. But it's possible that you would want to drill into the ARIA role itself if you wanted to get to the raw data. And so the ARIA properties allow you to get to the raw ARIA role data that is coming from the AJAX app. We also added a property called provider description. I've emphasized over and over that we try to hide the provider from you. You shouldn't need to know who the provider is. But if you do want to know, you can ask for the provider description, which will tell you, oh, this came from WPF, or oh, this came from Win32, or oh, this is actually an MSAA application that's being bridged through UIA. So that's provider description. There's some other new patterns. The synchronized input pattern is one that application framework developers can build into their frameworks so that if you're automating that framework, you can send mouse or keyboard input to a control and then find out whether it's gotten there or not. Oftentimes automation can be a little brittle. It'll send an enter key to a button and it somehow won't get there and then the automation will hang. And so synchronized input pattern can really help with that as long as it's built into the framework. The legacy MSAA pattern is one for fans of the original MSAA. If you really like MSAA or you have code that legacy code that uses MSA properties, but you think, boy, this whole caching thing and the twice as fast access sounds pretty cool, you can have the best of both worlds. You can use UIA to do your queries and your searches, and then when you've got an element, you can query for the legacy MSA pattern, which will give you access to the original MSA properties coming from that element. That's very cool. And then there's some new events, including menu mode events. I just have to show this to you because it's hard to explain any other way. Menus, accessibility always found it easy you always get menu open close events when pull down menus are opened. But we never had a good way to expose when you were in menu mode like this. When the keyboard focuses on the menu, but you haven't pulled anything down. And so now you get a menu mode start event when you go into menu mode, and then a stop event when you come out again. So those are some of the new patterns and properties that are made available with the new UIA in Windows 7. I want to take a few minutes now and talk about what it takes to build great UIA providers. This isn't new. This is not new with Win 7. Providers that you built for Vista will run just fine on Win 7. The API is just the same. I'm taking time to talk about it because it's so important that we build great providers. The accessibility of your application depends on the quality of your providers. And so it's key that you do this well. And so I think it's worth taking a few minutes just to touch on how you do it. The first question is, when do you need a provider? Because you don't always need to build one. If you've stuck to the standard controls in your framework, if you're just using plain Win32 controls or plain WPF controls, you probably don't have to build a provider at all. Just set good properties, good names on your controls, and you're all done, at least as far as programmatic access goes. But if you've started customizing controls, now you may need a provider. If you've changed the perceived properties on one of your controls, like if you've custom painted it so that the name that a sighted user would see is different from the name that a blind user would see through accessibility, then you need to change the name, the accessible name of your control. There is an API called the Dynamic Annotation API that lets you just change properties. It's almost like markup. You sort of scribble on the control and change the name. And it can get you out of writing a full provider if all you need to do is update some names. So that's pretty cool, and you may want to check that out on the Accessibility Dev Center on MSDN. But if you've added new abilities to your control, say you've taken a button and made it a split button, or you've built a fully custom control, then you're probably going to need to build a provider to expose those abilities to UI automation. The other case when you may need to do this is if you're building a whole new UI framework. So the Silverlight team at Microsoft needed to build a UIA implementation for Silverlight so that Silverlight applications would be accessible. Assuming you have to build a provider, it's not that hard, so don't worry. The first step is to build a COM object that implements iRawElementProviderSimple. Sorry, it's kind of a mouthful, but that's the name of the simple interface for providers provider for elements, iRawElementProviderSimple. It does two things well. It queries for properties, so there's a method called getPropertyValue that UIA will call into with a property ID, and you'll set up a variant and return that variant with the value of the property that was asked for. And then it can also query for a pattern implementation. A call-in would say, do you have the invoke pattern? And you can either say no, or you say yes, and here's a pointer to my implementation. Once you've got that COM object done, you're going to connect it up to the outside world through wm-getObject. You handle that message, you create an instance of your object, and you return it through a special UIA function. There's a sample for this up on MSDN. I'll walk through it in a couple slides so you can see how this looks. Beyond the simple interface, the other main thing you need to do is implement patterns to the degree that they make sense. As I said, control patterns are like object orientation for UIA. And on the provider side, they are exactly interfaces. They're just interfaces on your object. Actually, they're interfaces on some object. So when you get a query for invoke pattern, you return a pointer to something that implements the invoke interface. That could be on the same object that does the simple interface. It could be on a different object if that works better for whatever you're doing. Half the work here is just figuring out which patterns make sense to implement. So going back to my combo box example, combo box implements IRAW element provider simple. It also implements expand collapse and value. It doesn't implement invoke. It doesn't implement table. It doesn't implement text. More is not better. You want to implement exactly the control patterns that make sense for your control. There's a great guideline for this in the MSDN Developer Center where there's a list for each control type. What are the recommended patterns that are generally done for that control? And so you can use that as a reference if you're trying to decide which control patterns to implement. Once you've decided, you go ahead and implement them and then hook it up to the getPatternProvider method on the simple interface, and you're ready to go. So let's take a quick look at what this looks like. As I said, this is up on MSDN. The name of the game here is we've got a custom checkbox control. It's not particularly special. There's no reason you would really want to use it, but it's just an example. You've got a checkbox, it's custom, so you need to do accessibility for it. So here's my, it's not mine, I didn't write it, but here's my checkbox proxy. It's a COM object, it implements IUnknown, IRAW element provider simple, and iToggle provider, which is the recommended pattern for checkboxes. So there's some interesting stuff going on here. We've got a pointer to the UI control itself. The author here separated the implementation of accessibility from the implementation of the object, which is a really good idea because the control might be destroyed, the window could get closed, but an accessibility app might still be listening, might still have a reference to your element. And so you don't want closing the control to close all the accessibility objects, or else you'll get a crash in your application. So they've done the smart thing here. It's a separate object with a separate lifetime, but with a reference to the control. It's also got an alive flag to indicate whether that control is still alive or not. So I won't have time to walk through the full implementation, but just to show you some highlights, we've got a check alive function that if the object isn't alive, the correct thing to return is RPC disconnected, the error that indicates the control doesn't exist anymore. And then the control, when it's being closed, will call the proxy's disconnect method to set falive equals false. This isn't the only way to do it. This isn't a standard. This is just the way we did it, but it's a pretty reasonable way to go about this problem of lifetime management. We've got some standard COM stuff. In getPatternProvider, we check to see if we're alive first, and if we are, then we're going to see if the pattern that was requested was the toggle pattern. And if it is, then we'll return a reference to ourselves, since we implemented the same iToggle provider on the same object as everything else. So we return a reference to ourselves, and we're done. GetPropertyValue is a little longer because it needs to handle each of the properties that make sense for this control. But it's the same idea. We check to see if we're alive, and then we start going through to see which property this is. The sample supports a few. There's access key, there's name, there's control type, and any individual handler here is pretty easy, pretty simple. For name, we ask the control for its name, and we strip out the accelerator symbol and then return it as a beaster. Control type's even easier. It's just an integer, so we just return the control type. Is toggle pattern available? You bet. We just return true. So any individual one of these is fairly simple. There are a couple other methods on the simple interface that you want to look up on MSDN to see how you implement them, but they tend to be boilerplate, which is why I'm not going to go through them right now. I want to run ahead to the toggle pattern, and toggle has both a method and a property. The method is toggle, and so it's going to take the toggle command and then call through to the control to tell it to move to the next state. And then getToggleState is going to ask the control for its checked state and then return, and then it takes the specific answer from the checkbox and turns it into universal UIA answers. So checked becomes toggle state on, mixed becomes indeterminate, and so forth. You may be thinking, this UI implementation doesn't do very much. And you're right, it doesn't. That's the point. They're not supposed to think very hard. It's just taking the specific language, you might say, of the control and turning it into the more universal UIA language, taking the specifics of toggle and converting them and so forth. So that's it. That's the whole provider for the checkbox. And then the only other piece is the hookup. So in the checkbox control, which I'm not going to go through at any depth, but in WM get object, we create the proxy object if we don't have it yet. And then we call this special function UIA return raw element provider with the hwin, some wparam and lparams, and then a pointer to the proxy. And it will take care of doing all the add refs and making sure that that all the infrastructure work is done to return it correctly to the client. So quite straightforward. And that's it. That's the whole provider. There are a couple of topics that I should at least mention in passing. If you have a control that's complex, like a list view that has children, if those children are full hwins, then UIA will pick them up for free because it mirrors the hwin tree. But if you have non-window children, which a list view does, then you also want to implement the fragment and fragment root interfaces, which will help you to help with tree structuring and hit testing and all the stuff you need to do when you have children. As for events, you also want to think about whether your provider should be firing events. The guideline would be if there's anything that a user would notice, you want to fire an event so that the accessibility system will notice it too. And there's a capability to check for listeners as well. So if it would be costly to generate the data for your event, you can check to see if anyone's listening, but if it's cheap, just go ahead and fire it. Now I can finally talk about two of the new things in Windows 7. Custom patterns and properties, that custom extensibility thing I mentioned earlier, allow clients and providers to exchange data beyond the original accessibility design. Custom work needs to be done on both sides. The provider needs to respond to the question. So let's say you wanted to ask about the color of a control. We don't have color in UIA. So a provider could say, okay, I'm capable of handling the color property, and here's the handler for it. So if I get asked for color, go run this, here's how I'll respond. And then the client needs to ask for color. But if both cooperate, then you can pass color back and forth, even though we never included it in the original design. The other custom facility in UIA is custom proxy support. If you've got a provider that you can't add accessibility to, maybe it's legacy, whatever reason, you can't add a provider directly into it, you can create a proxy that will run within your client process on the client side to provide accessibility data on behalf of that provider. We actually do exactly this for the old User 32, the old basic controls in Windows like button and checkbox. We didn't want to go in and augment them with accessibility code directly, so we built proxies that run on behalf of those controls and expose their accessibility implementations. So this only runs within the client process. Registering one of these isn't a global action, so its scope is limited just to your application. So let's wrap up. One thing I really want to talk about is to note that this is not all of accessibility. Programmatic access is important, but it's not the whole story. There are other things that you want to make sure work. For instance, you want to make sure your application is keyboard accessible, because a user with motion impairment may find it difficult to use a mouse and so would want to use your application just with a keyboard. You want to make sure your application runs well at high contrast and high DPI so that low vision users can use it. You want to make sure that it works well for users with slower reaction times. Some applications nowadays seem almost like video games. If you don't click on the notification fast enough, you'll miss it. And so you want to make sure that you stay up long enough that users can get to can see your UI and really think about it. And I'd emphasize accessibility isn't a yes-no question. It's really a spectrum. So some applications are totally accessible, some are totally not, and then some are technically accessible, but say it takes 37 tabs to get to your email message. that would be technically keyboard accessible, but really not usable. So you really want to think about accessibility like usability for a specific audience. And since that audience grows larger every year as our population shifts older, building good accessibility for your application is really a way to sell more copies. So it's the right thing to do, and I encourage you to think about the whole of accessibility. The Microsoft Developer Center for Accessibility on MSDN is a great resource for these broader things as well. Just a quick word about managed clients. If you've used the Managed Client API for UIA, you may be wondering what happened to it. And if you want to work from managed code, you now have two options. One is to work through the new COM API through COM Interop. We designed the API from the ground up with .NET interoperability in mind, and so there's no problem with TLB importing it and using it that way. This gives you the fastest performance for programmatic access, and it also gives you access to some of the new patterns and properties that aren't available in the .NET framework yet. The downside would be that the imported COM interfaces are not identical with the managed client interfaces that were there before. So if you have existing code, you would have to do a little bit of porting work. And some Win32 controls show some slight behavior differences through the COM API than they did through the managed client API. But on the whole, this is what we recommend. We think this is the best way to go, particularly if you're writing new code. If you have a lot of existing managed code, you're welcome to stay on the existing managed client library. The system.windows.automation namespace is fully supported and runs without any change to your existing code. The downside would be it may run slower when you're accessing MSAA applications, and some of the new patterns and properties that are premiering in Windows 7 may take a while before they appear in the next .NET framework release. So if you really want to use the new patterns and properties, you'll want to use the new COM API. But there's nothing wrong with staying on the managed client API as well. So my call to action. If you are consuming accessibility data, you should totally take a look at the COM Client API. It's very powerful, it's very performant, and I'm really excited about it. So I think you should give it a try. If you're building applications, please make sure that if you're doing custom controls or frameworks, that you think about building UIA providers. If you don't have any accessibility support yet, UIA is much better to build than MSAA. It's easier to build, it's more modular, it's more object-oriented, and there are bridges to make it backward compatible with MSAA. So consider building UIA providers. And last, think about the accessibility needs of your customers when you're building applications. It's the right thing to do for the set of people who use it. It makes the computing ecosystem much easier to use and allows our customers to realize their full potential. So with that, I'd like to say thank you for listening. And if you have any questions, please come to the MSDN Accessibility Center and ask your questions on the forum there. Thanks very much. Goodbye.